Welcome to a new edition of the Heat Treat Podcast. Today we're going to talk LPC, low pressure carburizing, and we got one of the most influential people on the Heat Treat, actually specialized in low pressure carburizing, Dennis Beauchesne. Is that how you actually pronounce your last name, Dennis? Beauchesne?
Beauchesne.
Beauchesne. Sorry about that. My French is not that good. How are you, Dennis? Long time no see.
I'm very good, and a long time no see. Yeah, it's really good to see you again, and especially talk to you for sure. So thank you for having me on.
No, thank you for your time. And I saw you on the Monty list as number 8 of the most influential people on the heater industry. And our goal here is actually to have the best of the best explaining processes to the audience. So today we have a great show with a very, influential power player that actually knows the stuff. So just tell us a little bit about yourself. How do you start in this industry? Once you told me, I remember that you started in the industry as a field engineer. How long was that? What brought you to the heat industry? Can you share a little bit of your professional career?
Sure. I don't want to bore too many people for too long, but yeah, we started as a field service engineer. I started working on environmental chambers and ovens, and decided that once my son was born, that wasn't going to do it because there was another field engineer that was 40 years old. He had bad knees, and I said, well, I'm not going to get to that point. I need to change jobs. So I begged and borrowed to try to get into the sales part because customers. I could work with the customers and talk to them quite a bit with field service and understood the equipment and the processes. And then eventually got into the heat treat business or heat treat industry as an agent or a rep down in the Carolinas. And ECM was one of the lines that I bought into a rep firm there and started working through them for a few years as an agent, and then was hired on actually in April, it'll be 20 years with ECM in North America here. So that's kind of how it worked. Yeah, it took some technical information that I learned as a field service engineer and brought it into sales, and now general manager of the company.
Right. We met like 5 to 7 years ago, and I believe we met in what was it in Bermuda, right?
Exactly.
And
yes.
we met in Bermuda, and when we actually got introduced, I told you that it's like this dude is really smart, right? And he's just a great engineer to lead the company, but as well that gives you a lot of strength on sales, right? Will you say that the engineering technical aspect is what gives you strengths in order to sell the product?
Well, I think it's very important to understand the product that you're selling and what the benefits are for the customer. And of course, in sales, you're trying to solve a problem. So I think if you can take your technical skills and apply them to problem solving for the customer, then things go well for you typically. And if you know your product and you know the process and how it can work with the customer, then yes, it's a good lead in for a sales.
So today, the content of the show, we're going to talk about LPC, low pressure carburizing 101 from the very best, Daniel Beauchesne. We're going to talk about the carburizing process that goes on. There's this process called pulsing. Is it pulsing correct or pulse?
We tend to call it boost diffuse.
Boost diffuse, okay.
Yep.
Boost diffuse, the gas quenching, high pressure gas quenching, the most common misconceptions of LPC, high pressure gas quenching, and of course, constant pros. So this is the content of the show today. Of course, Dennis been around in the industry for a lot of time, has visited, I assume, many companies, with many different applications, and he has a great oversight view and a personal opinion of where the industry is going. The first conception, maybe it's a misconception, then, is that is LPC 80% or more for automotive, or there's other applications that actually can use this process and cover the volumes that are needed for this type of equipment? Is it mostly automotive, or there's some other industries?
Well, I would say over the last 20 years I've been involved, for sure, the last 25, it's been mostly focused on automotive because it lends itself very well. The equipment lends itself very well for an automotive plant and automotive production type of environment. But LPC has also been very prominent in aerospace, not typically the one of your mentioned that vacuum carburizing and other vacuum processes are also prominent in the medical industry today too. So I think that's where those are the markets. But yes, as you said, at this point they're very dominant in automotive markets.
Yeah, so and we'll go through that at the very end, and the conclusion of this episode, right? Because we all know that the electrical vehicle is coming. Actually, we have a great guest next week that we're going to talk about the EV and the implications. But the question is, with the EV and the amount of capacity that there is on the industry. And also with the autonomous vehicle, when the volumes are going to drop, where's that capacity is going to go, right? Who's going to cover that? So, but we'll talk about later. But let's start first with the LPC process. So if you were to give us a class, on LPC, how would you start?
Well, you start with explaining, I guess, the basic understanding of carburizing and why we do it. So I think something that I guess our audience are going to be a lot of heat treaters or people that are trying to get into heat treat business or are in it or are looking for this process. So we usually start out by saying gears and steel that are processed, especially in automotive, start out with a low carbon content, and the carbon content is what adds strength to the gears. So in starting out with a low carbon content, that is what's possible to machine the part. And it's really important that the part is not hard, of course, when you're machining it, but it's very important in the fatigue life or in the operation or use of that part. For instance, gears in a transmission or gears in your axle, they have to be very strong and very hard and on the surface. So in order to do that, you have to almost impregnate or inject carbon into the surface of the steel. And in that fashion, you typically need to heat the steel up so that we can make some room for the carbon to get in. And then you have to have the steel in an environment where carbon can be absorbed into the steel. And then, of course, you don't want too much carbon in it, and you're looking for particular case depth, which is what the carbon profile, shall we say, on the gear teeth is called. And different gear teeth have different work loads, and those work loads require certain case depths. And also core hardness is also an important part of the factor. And we'll get into core hardness when we talk about quenching next. But for the case depth, it's typically time and temperature. And so the typical method that's been going on for the last 150 years or even longer than that is atmosphere carburizing, of course.
Yeah.
And, you have to,
I'm an atmosphere guy.
Right. We know, and that's great. I mean, it's what
that's what I'm talking to you, because I want to learn about the LPC.
Oh, okay. Yeah, you want to come on to the good or the evil side? Which side is it that?
And we had a podcast with Tracy,
yes.
And he's an atmosphere guy as well, right? Yeah. And what I told him, I believe both processes have a place on the industry, right? Mm-hmm. Yes. It's not like I'm an atmosphere guy or if I'm a vacuum guy. It's not like where I'm a Republican, right? But from day one, the customer is going to go this way or it's going to go that way. I think that's really clear, right? It's a humble question.
For the most part, yeah. I think once they're starting designing the part, there's some preconception of which way they're going to go. And then you're right, there's some crossover somewhere where as a LPC guy or vacuum guy, I might try to convince them to go vacuum, and Tracy might try to convince them to go atmosphere
Right.
or vacuum.
But
In his case,
it's up to the customer, right? I mean,
it really is up to the customer. I mean, everybody shows the pros and cons, and it's up to them to decide, how they want to operate. And then sometimes the proof is in the pudding. It's put the gear to the test and see what happens. And then there are a lot of other considerations as well. I mean, you have to consider what kind of facility you have, what kind of facility you want to have, what kind of facility you want to operate. Do you want a vacuum kind of environment, or do you want an atmosphere kind of environment? So there are a lot of considerations to make when you're trying to decide on the carburizing method for your particular components and how it's going to operate in your plant.
That's fantastic. But I'm sorry I actually interrupt you, but you were explaining us LPC 101. You were talking about time and temperature.
Yeah, time and temperature. So and time and temperature is crucial to the case depth that you're requiring. The differences that we have in vacuum carburizing as compared to traditional carburizing, let's call it, is that in vacuum carburizing, we typically do things a little bit higher temperature. So where you might be carburizing at 16 or 1700 traditionally, we could carburize anywhere from 1700 or 1600 if you want even to go that low, to 1800, 1900 degrees Fahrenheit. So some of those things are advantages in the fact that you have a shorter cycle time. So if you are less time at temperature and you are injecting the carbon properly, and you get the proper case depth that you need, then obviously you're going to save cycle time, and you're going to get the part that you want as well. So to go on further from that, of course, you also have to consider the materials that you're processing at those temperatures to be sure that you're not you don't have any issues with grain growth. Let's say you need to recrystallize or get your grain growth down. So you don't want to talk about that, and you don't want to get into carbides on the surface as well for the process. So in that. In our process, the vacuum chamber is always at vacuum, of course. We're always running the pump, and I think it was one of the things you described as well. We're pulling gases out of the cell, and when we do that, we are trying to be much more precise at the amount of gas or the amount of carbon that the parts see in that time frame. And also, we want to keep that pressure or vacuum level in the cell to be the same and consistent throughout the cycle. And that's part of vacuum carburizing, or low pressure carburizing, as we know. The two names are being used quite often in the industry. So basically we can run things at higher temperature because we're in a vacuum chamber. We are using a piece of equipment that is completely graphite insulation inside. So we're not worried about alloy components, let's say, that might grow or crack or creep as you're processing them in the furnace. So there are things to consider at the higher temperatures, of course, making sure your alloy fixtures are capable of high temperatures, those kinds of things. So in the LPC 101, let's say, those are some of the most important things. We can run higher temperatures. We can also run near the potential carbon for the parts. So, and the steels are rated, up to 1.6 or 2% carbon, and you can get near that when you're pulsing the carburizing gas inside the furnace. A couple other things. The gases are different. In vacuum carburizing, you would use acetylene. Today, we use acetylene. I can tell you years ago, we used propane. There are still some processes or parts that are still being processed under propane, and it's for other reasons. And there are also companies out there that are using mixed gases in the process as well. But
So
the base,
just to recap there, you know, so
sure,
on the vacuum vessel, you load your parts in your fixture, you close the vessel, you pump everything, and you create a vacuum, and you got your heating elements, you know, bringing temperature to you say it 1800.
sure, 1800 is a good temperature. Yeah.
1800. And just not to confuse the audience, there are two types of gases: carburizing gas and quenching gas. Let's talk let's talk about the carburization gas method. And you say acetylene or propane, so, right?
Yes.
So just can you go deeper on you say pulsing, but first you referred to it at the beginning as boost diffuse. So can you just explain us a little more about how is this process? How does this take place? Time, temperature, boost diffuse, injection of more carburizing gas. How does it works? Just if you could go deeper on this, that'll be appreciated.
Sure, no problem. Yeah, that's part of the 101 class as well. So once you have the parts in the chamber, now you have it under vacuum. You're basically using a recipe that's been recipe developed through a simulation software. Typically, there are several out there in the marketplace, and I believe each supplier has their own version of that. And that recipe will be developed based on the boost and diffuse method. And the diffuse cycle will be nitrogen. The boost cycle will be used with the carburizing gas, which would be acetylene. Typically, you would have, in our systems at least, we keep them at a constant pressure throughout the cycle. It's part of our patent. And during that time, the first few boosts are usually longer. So the first boost of acetylene is longer than the rest. And then you would slowly reverse the process where you would have longer diffusion cycles at the end. Because also what we can determine through the simulation is what the final carbon will be on the part. You may be carburizing at each boost. The simulation software may tell you that you're at 1.2 to 1.4 carbon potential during that boost, but you only want a 0.6 or 0.7 or 0.8 or 0.9 on the part at the end, depending on its process need or its work need. So you would set up your final diffusion, and that's typically under nitrogen. With the process of using boost diffuse method, you typically you would use 90% less carburizing gas than you would use in a traditional gas furnace or a carburizing gas furnace. That means that you're only injecting about 10% of the carburizing gas at a time to achieve the same case depth that you would in in an atmosphere or traditional carburizer.
When you boost and you inject carburizing gas, you also need the heating elements to go higher in temperature. Is that right?
No, the temperature stays monitors the same. You would get your typical uniformity that you have inside a cell. You maintain your standard temperature on the load at all times.
So you maintain 1800 to
Yep.
the entire, let's say we call it soaking.
Yes.
Right. Mm-hmm. And then you get boosts of injection of acetylene. Is that will that be accurate to say?
That's accurate. You would have a boost of acetylene for the carburizing gas, and at the same time, you wouldn't change the temperature, but you would change probably the vacuum flow. In other words, you would probably have more vacuum suction, let's say, at that point to remove the gas for that set pressure that you're working at.
So you're going to inject the gas, and of course you're going to mess up with the vacuum because you're actually injecting something, but the parts are sucking it, right?
Yep.
And after that boost, I assume you're gonna suck the remaining acetylene that there was in the chamber with the vacuum pump. Will that be accurate?
Exactly. Yes. So you boost, and the gas will crack on the surface of the parts. The carbon will diffuse into the part, and then now your next step will be nitrogen to allow the carbon to diffuse into the part a little bit further. So that's why you want an initial boost that's a little longer, just so that you can get through that surface and start that carbon to penetrate through to diffuse into the part.
How many boosts and diffuse are usually on a standard or on our standard carburization cycle?
Well, I'm gonna use what my metallurgist tells me all the time. That depends. It's
I hate that answer, and it's so common on this industry, right?
I do. I hate that answer, but I'm going to use it here. But
we get it a lot.
Yeah, that's right. It depends on the temperature and the case depth particularly, but I would say anywhere from 3 to 10 boosts can be part of the cycle, depending what you're looking for metallurgy and what you're looking for case depth and at what temperature you're at as well. That's where sometimes the higher temperature and a shallow case, you have maybe one shot, you have one boost. So it doesn't always work out that you want to go to high temperature, especially when you have a shorter case. But for deeper case depths, like we're talking about 1-2 millimeters or 250 thousandths, that's where the higher temperature comes into play, and where LPC has an advantage to actually apply a deeper case at a shorter time cycle than what's out there in the industry today. So
one of the questions I wanted to ask you, because there's we had a podcast with just vacuum quenching temper. Is that accurate to say?
Sure.
No carburizing.
Yes.
We had a podcast about that, and there seems to be a bunch of companies there that actually sell vacuum systems, but they do not offer the LPC capability. What's the difference from a standard vessel that it's able to do vacuum heat treating and gas quenching from a unit that it's able to do vacuum carburizing? Is there some what's like the difference, right? There's many single vacuum vessels that they're only devoted to vacuum heat treat and quenching, but not carburizing. And apparently there's a couple of manufacturers that their strength is LPC, being the company that you represent one of them.
Mm-hmm. Yeah, so the differences are the hot zone design, the injector design, heating elements. Also, I would say the vacuum pumping system and how it works with the boost diffuse method. It's not just a simple vacuum pump that's sitting there pumping. There's some interaction between the gas and the pumping, of course. So that is the basic function difference in the equipment. However, reversely, an LPC furnace can be used for vacuum processing as well.
Right.
So
right.
You can use it for brazing and hardening and all of the other processes as well, and have LPC there as another feature.
What about nitriding? Has anybody thought about nitriding on a vessel?
Yeah, typically not nitriding. It requires a different makeup material inside. So it's a different furnace design. Yeah.
Okay. So is there anything else we're missing about heating up the parts and boosting and diffusing carburizing gas?
I don't think so. I hopefully my description was clear.
It was fantastic. Actually, I did get something this time.
You picked up on something. Okay, good.
I did.
So class was successful. We'll send your certificate. Good.
Well, we're actually just 50% from the beginning, right? Also, the hypergas is also us, right?
Can and it doesn't have to be as well. It has been the trend. I mean, one of the maybe we'll talk about pros and cons of the equipment as well, but one of the reasons that it's not only a process that is starting or has been dominating the automotive business for the last 20 years has been the cleanliness of the systems and the system design as well, and how it fits into the plants. And of course, along with that comes the quenching media and oil itself. Typically in the automotive industry is something that the manufacturers have to deal with. They have to deal with bringing in oil, adding oil to the quench tanks. Of course, there's flame curtains as well. So from a safety standpoint, a lot of customers have been looking and have installed a lot of gas quenching equipment as well. So LPC and vacuum carburizing have always been synonymous with gas quenching, it seems like. But we as a company have provided, I don't know, 40 or 50 now oil quench systems along with the vacuum carburizer, or some vacuum carburizers with both on the same system.
But with the
So-
standard, maybe that's a misconception as well. So LPC, what percentage of the time actually comes with high pressure gas quenching? 80% of the time?
Oh yeah, I would say it's at least 80%.
It's right. So if you go, I want to do an LPC with oil quenching, that will be like a I have seen that, but it's not like the standard of the industry. Will that be accurate to say?
I
And
would
I don't
say
want to, sorry to put you on the spot, but
not a spot. It's I would say pretty accurate that it's probably 80% is gas quenching, maybe a little higher. But I can tell you that the things are changing, and a lot of people are understanding the benefits of the vacuum carburizing, and then want oil quenching as well. So want or need, as other people have explained it, with much larger parts, it's more difficult to gas quench. Even though I can tell you that 20 years ago, I can remember trying to gas quench some larger cross-section parts, and we're not as successful. But today, the gas quenching technology is really gone leaps and bounds in the last, even 5 years. Developments coming further and further along. Larger motors, better gas flow, more fluid dynamics engineering in the gas quench. So those things are happening, and there are more and more applications turning to gas quench these days. And it's not only for distortion, but it's which can be better in gas in some cases, but it's also for the cleanliness of the process, and cleanliness of the parts as well. There's some processes after that don't need to be worked on with the gas quenching finish.
Okay, so I'm gonna ask you the question that you might be asked all of the time, but we're just trying to add value here. So, like the big pros of LPC and high pressure gas quenching will be cleanliness, right, of the process. No IGO, because there's no oxygen on the vessel, right?
Yes.
And less distortion of the part, right? First of all, I would like to be clear. There's some distortion on the process, right? Distortion cannot be eliminated as a whole. It can be reduced. And this is, so it's false. This is a question I'm asking you. If somebody tells you that they're going to get zero distortion out of this process, that's a lie. Will that be accurate to say?
Yes.
Okay. Yeah, it's like saying that the process is perfect, right? Which it has its faults. And regarding the cleanliness of the part, is in there remains of acetylene on the chamber, because when you actually carburize, and on the atmosphere side, we used natural gas, right? And since we're carburizing, there's carbon involved, right? And carbon is going to solidify it, and we're going to have a bunch of soot on the chamber. I have seen some of the vessels, and also they have to be well maintained in order to keep the cleanliness of the part.
Yeah, to talk about the potential soot in the chamber,
yeah,
it's very minimal. It's 3-4 months. You go in there, and it's very, very minimal amount of soot or any accumulation as well. We don't see any accumulation on the parts. It's mostly some in the chambers, but that's really not a factor on the whole decision, let's say. But for the vacuum carburizing equipment, it's also a bonus to have the equipment being able to start up quickly, to shut down quickly, to be able to work on it fast. Also to have it in your plant, in your machining centers, so that it's not a separate heat treat area any longer. And that's those are some of the other benefits to the system.
And now let's switch to quenching media. I know that you can quench with different gases, like there's nitrogen, there's helium, and there might be argon. Is that accurate? Can you get quench with argon?
You can do argon, but it's not typically one used.
It's not standard.
Common. It's not common, no.
Okay, so can you help us understand when it's better to quench with nitrogen, when it's better to quench with helium, and when will you quench with argon if there is a need, and what are the benefits on each ones? Nitrogen generators have gotten popular and more popular in the market, and I know helium it's more expensive than nitrogen. So you just could let us know how the gas quenching process is and the quenching media, the benefits of using one against the other.
Sure. I would say the most common one in the industry is nitrogen. It's the least expensive to use. It's readily available. As you said, there's nitrogen generators out there today. I'm not sure that they're at the right purity level just yet to be used. Another reason that customers use gas quenching is to have a very clean surface on the parts, not to have the finish deterred by.
How pure does the nitrogen has to be?
I believe it's 3 nines. I'm not sure.
Okay.
To be honest with you.
Okay.
So nitrogen is probably the most common one. It is of course more dense, so it takes more energy to move it around, and to get the heat exchange directly from the water-cooled heat exchangers, typically that are on the gas quench. It is most common used, and it is desirable to have the process completely use nitrogen. So that's where customers are looking. When the subject of helium comes up, is typically when you have a part that needs a higher core hardness or something that's more difficult, a really large load maybe. There are studies out there for core hardness increase. Maybe there's a difference between 1 or 2 HRC difference in the core hardness if you're using helium versus nitrogen. And then of course, when you're using those gases, you have to consider the vessel that you're using them in. The equipment design is really important. As the nitrogen is more dense than helium, you can move it and you can direct it where the helium is a little bit more interesting, I'll say, to move around and to keep it flowing through the chamber. But obviously has more capabilities of removing heat, but it also has to be considered how it's moved and what the quench cell, how it's designed. So that's really a major factor. To talk about argon, I would say argon is not used very much in the automotive business or in conjunction with LPC as a quenchant. Obviously, when you have parts or material that you're trying to, let's say, use a cover gas or argon, or it's sensitive to nitrogen or helium, then you would use argon. But of course, argon is even more dense and is more difficult to move around in the gas quench. So you would have less quenchability, I would say, in a quench cell that was designed for, let's say, nitrogen.
Okay, and talking about maintenance procedures, how often do you have to maintain one of these? Of course, there's daily maintenance, weekly maintenance, and multi-maintenance checklist, right? But what's the standard time frame for like 6 months retrofit? There's the graphite zone in there. What's the lifetime? On conventional heat treating furnaces, we typically service the equipment every 6 months. It's a minor repair, and we do a major on 1 year, right? And it's like every machine, right? I'm not saying which is better or not, right? You have to maintain machining center, you have to maintain forging presses, casting furnaces. So I just want to understand what's the correct maintenance procedure for one of these systems. Where to look for, where not to look for. Most common mistakes that you see that some of the installed bases do what did they miss? What do they do well? I mean, just trying to understand how you maintain this stuff.
Sure. So for maintenance, yes, you're right. It's a machine. It needs to be maintained.
Every
Um,
machine is to be maintained.
Absolutely. And of course, all machines come with a maintenance schedule. It's recommended by the supplier. We try to talk customers into following that, but of course, it becomes more difficult to follow it to the letter. So I would say that typically, if you're using a large system with multiple batch units, as you know, most of the automotive companies, it's more of a continuous batch operation with a central quench system. And in those systems, you might change the vacuum pump oil every 3 to 6 months, depending on the carburizing gas that you're using and the amount of carburizing gas you're using. And first of all, you have to talk about the difference. With a vacuum carburizer, you can have a complete system cooled off in 5 or 6 hours and able to go in there to do the maintenance. So your overall time downtime is shorter in the fact that you can take it down. There's also alternate methods of having a backup pump so that you can be servicing one pump while you're still operating with the second. So changing the pump oil is not really a downtime for the system. I would say that once a year, as you said, you go in and change your seals on any of your doors. Some systems don't have any hot seals, which is even better. And some systems have these continuous batch systems that can move away from the production line and be completely maintained offline while the rest of the system is operating. So there's some benefits to that as well. But yeah, proper maintenance, I would say gaskets, door seals, vacuum pump oil is probably the most important items. Also, the electrical feed-throughs are important on the heating cells, and those are typically replaced once a year. And then as a vacuum chamber, the hot zones you talked about a little bit, those typically run anywhere from 8 to 10 years, needs to be completely replaced. And that's depending on your leak up rate on the vacuum furnace and how well you maintain your system feed-throughs and your thermocouple ports and those kinds of things.
Right. I'm pretty sure that you have seen companies that they do an amazing job at maintaining the equipment, and of course, there's the other side of the coin. Companies that their strength is not on their maintenance department, and the equipment gets pretty deteriorated in 6 months, let's say, right? I have seen both when there's companies that have been running equipment that was manufactured 20 years ago, and they have just a great maintenance department, and they keep upgrading the controls, and they do the right things, right? And I have seen companies that you supply them a brand new line, fully automated, and in 6 months, the furnace looks like it's been 5 years without maintenance at all. I'm pretty sure you have seen a couple of these things.
Yeah, we've seen both sides of the gamut, of course, but what's interesting is that you learn things from both of those.
You do?
You learn that the people, the customers who maintain that equipment properly, you try to work with them and say, okay, well, let's try to take this a little bit further and see where we can go to try to get some more life out of, let's say, the oil or the seal or whatever. But the other customers that don't maintain give you a gauge to help the other customers. So you tell them, we have a customer that doesn't maintain this seal at all, and it lasted him 3 years. So you have some data to go back to the customers that do all their regular maintenance and give them a little bit of more allowance. It's experience on the equipment and how you can help the customers through their maintenance cycles, and obviously updating your own documentation to indicate what is absolutely necessary to maintain. And of course, you point those things out, and like you said, some of them you go back in 6 months and they look like they're 5 years old already. Yeah.
And our market trends, because I know you're a guy heavy on automation, IoT. Uh, is that like a market trend right now? When a customer is asking for a sale, how automated are your cells? Fully automated? Do they need a guy, loading and unloading fixturing? I believe automation is going to come even harder than it's coming right now. So, is the request for manual, semi-auto, or fully auto? Because we also had a podcast with John Hubbard, and we were talking about lights out heat treat shops. Have you seen a couple of those?
So it's steam systems is out there. I mean, there are people designing those systems. We see more plants coming to us with AGVs, and how do you interface with the AGV? How do you interface with the robotics? And how do we take parts out of bins and robotically load and unload fixturing? So that's those things are all being done and being quoted. So it's very interesting.
I got a question there because also I actually talked about automating loading the loading and unloading procedure. And since we get distortion on the racks, and the robots have very they don't have a lot of tolerance because it's millimetric. How do you attack robotics when you actually have a distorted tray?
So fixturing, of course, is a very important part of the parts.
It's what consumes the most labor.
Yes, it does. It does, and that's where most people are trying to automate the systems. So you're right. Warped fixtures are an issue, and you really need to work on that as far as whatever you're doing, flipping them, taking them out of service when they're too warped. What is too warped? What is too large? Because of course they grow, creep. So those parameters have to be set up before you're looking at robotics. Also, a lot of customers now are looking at CFC. So CFC fixtures will give you very precision.
Remember the Weir 101. What's CFC?
CFC. So carbon fiber.
Yeah.
Carbon fiber is being used in the industry for many years now, and probably people use it on the cars and all different places. But it's becoming more and more popular in the heat treat business. It lasts a long time if you take care of it. They're very fragile to be used in say manual kind of operation, but in a robotics cell or in an automation that is precise and gives you the same results every time, can be used very well and very successfully. So that's another option when you look at fixturing and integrating with robotics or automation. But CFC. Yes, there are systems out there today to handle the warpage of fixtures and loading and unloading. So it's out there. If you have warped fixtures, you can still use automation.
Well, I believe the challenge on automating, the load and unload of the fixture, and I'm talking about commercial heat treat shops.
Yes.
It's that you have a bunch of variety of parts that are loaded on a standard basket, which is not the case of these systems, because I believe the LPC systems that we're talking about right now are for massive volumes, industrial volumes on very few part numbers, right? So that makes things easier to automate with the gripper and the robot, right? When you have a little more flexibility, because you have to run different part numbers, the challenges of changing the fixture or changing the robot gripper or the way you load the tray, it's like a bigger challenge for heat treat shops, right? When we're talking about captives, I believe it makes sense to run automation when you're gonna heat treat the same part or parts alike in a very industrial volumes. That's where automation makes a lot of sense, right?
I would say that it's easier to justify in that case for sure, but it's not impossible for a heat treater to have different bins of parts coming in and loading in different baskets, having a different set of grippers there for the same robot. So I would say that something that ECM has explored and for sure has available, whether it's an ECM furnace or vacuum carburizing or whatever. That's something that's possible, to be able to take parts out of a bin, orient them into a basket, and build a load.
Here's a $1 million idea that I will share with the audience. If there was to be a company that their niche was going to be, not selling furnaces, not selling controls, just selling, automation for loading and unloading of baskets, I believe there's a niche. If there will be a company specializing not on selling you the furnace, not selling you the controls, not selling you the trays and fixturings, selling the solution to automate the loading and unloading of the heat treat process on conventional atmosphere or vacuum, there's a bunch of money in there, because as OEMs, the companies focus on selling the equipment, but the handling of the equipment, it's a totally different aspect of the business. I don't know, you will agree, there's some opportunity in there for an entrepreneur.
I quite agree, and it's part of our business plan.
It is.
Yes.
So okay, but
I don't know if you've seen some of our latest, automation advertising, but yes, it's part of our business. We would talk to anyone with a heat treater or a captive shop that's not using our equipment or using our equipment to try to interface robotics into the loading and unloading part of their scenario. So it's definitely a piece of business that is out there, and it's part of our ECM business as well. We have a robotics division, and we have a lot of other products as well, but we're mostly known for LPC vacuum furnaces, of course.
And so we talk about automation. Is there anything going on with IoT and AI on these processes?
I think IoT, AI, 4.0, all of those buzzwords today, and also processes are coming into play in different requests for quotes. So depending on how far along the company is, whether it's a captive or a commercial heat treater, those things are part of an equipment supplier's, let's say, offering these days. It needs to be part of it. With the advancements in computer technology today and IoT availability, it's something that everyone needs to look at and needs to understand it, and how can it be implemented in their equipment as well as in their process and their plant. So,
I believe also one of the big challenges is cybersecurity, because the big companies, the big corporations, they want to have IoT, but they're very restricted on how much access will they give you. What's your opinion on that? I mean, and there's a bunch of security breaches right now, but everything is going through connectivity and the cloud, and there's so much you can do with the little access that you get, because something that everybody's talking about is, hey, I want to have a remote diagnosis, right? Okay, but I have to be, I have to have access to your network. What are the challenges that you see? Some of the ideas that you might recommend you have in order for the OEM to be able to have an interface with the furnace itself, but the user being comfortable with having a remote connection.
Yeah, there are more and more requests for, well, I want to be at home and I want to dial into the computer. I want to into the furnace. I want to have an app on my phone to see what the loads went through. It's getting more and more requests that are coming through like that. But as you said, the security risks and challenges are there, and they're real. And unfortunately, it's like with everything, you have a few bad apples, and it ruins it for everybody else.
That's all it takes. That's all it takes.
That's right. So you have to work with what you have, and you have to work with the customer to understand the security risks and analysis, and try to work around those. Some you can, some you can't, and some are I would say most are very determined to keep you out of the system. And that becomes challenging when they want IoT. and they want to interface with the equipment in any fashion, or if they want us to interface remotely as well, it becomes more of a challenge. So it's a risk. It's something that's becoming more prominent with cybersecurity, and it's something we're going to have to deal with, because I think IoT and 4.0 are not going away. They're going to be more things we're going to talk about, because there are more and more opportunities to understand. For instance, we talked about service and maintenance. There's more and more opportunities to understand when to service a pump, when to service a gas quench motor, for instance. And all of those inputs, outputs need to be evaluated properly, and not just on site with the customer, but remotely from the supplier. And I think that's part of the ownership that a lot of customers are asking for now as well.
And just to finish our conversation regarding LPC or vacuum carburizing, what are the most common misconceptions that you hear from the industry that you get a lot, and you just go like, I got a script for this one, right? And I'm gonna ask you the first one, which I believe it is conceived that this equipment is very capital expensive, which is a considerable amount of money, right? It's industrial machinery, right? So I just want to know your answer to this one.
Okay, so we'll tell everybody how to handle this question. In vacuum carburizing, especially in low pressure carburizing, and especially in combination with gas quenching, the most important thing to do is to take a step back from the heat treat and not look at it as you're replacing a furnace with a furnace. Because now you're talking about integrating a process that is part of your materials that you're working with. So you have to understand that the material is going to be treated as it needs to be. In other words, the recipe will be developed for that material, for that case step, for that part. And as I didn't mention in my 101 session, is that once you have a load, let's say at 0.3 millimeters of case depth, the next load can be 0.5 millimeters of case depth for a different surface carbon as well. So those things need to be considered when you're looking at the whole investment. Also, things like facilities needs. There's no more hoods. There's no open flames. The safety has to be considered. Do you need pits, and are there special floors that you need? And all of those things need to be considered when you're talking about vacuum carburizing and investing in this type of equipment, because it's not really a furnace to furnace kind of discussion. And,
yeah, so
I guess I would also say that it's not as expensive as everybody thinks it is. But
right, I mean that's and I want to be very straight, right? As an instance, because you just hit the nail. I also run 2 heat treat shops with IQ equipment, right? Conventional and atmosphere, and you can find in the market very cheap used IQs for like $100,000, right? And that's cheap, right? But what you're saying is that you have to. It's not an apples to apples if you're comparing it that way, because you have to look, the wider processes. And another conception is that LPC is more suitable for captive heat treat applications rather than commercial. Will that be accurate to say, or what's your answer to that one?
Well, I would like to I'd like to convince everybody that that's not the case, but I would say currently today, and hopefully I can finish my career by telling everybody differently. But today I would say that it's probably the case is it's probably 75% or 70% captive and 25% commercial. But there are commercial heat treaters out there that are very successful at vacuum carburizing. They have it in their portfolio and they're able to sell it. I think the other things that need to be looked at in the future now is energy consumption, is also carbon footprint. And as I described earlier, with 90% less carburizing gas being used, an LPC furnace has less carbon footprint. So if a customer is looking down the road, or a heat treater is looking down the road and making investments for which process to go with, and the end result is that you can carburize, whether it's vacuum carburizing or traditional carburizing, and taking a look at what are the restrictions they're going to come up with in the future. Is carbon footprint and cost of carbon emissions going to play into their business plan in the future? I think those are things that really need to be discussed and talked about, because there are larger vacuum carburizing systems now with oil quenching that can fit into existing lines, existing atmosphere lines, and those things can be looked at, as well as also cycle time being shortened, having a vacuum furnace there for doing vacuum hardening with oil quenching, carbonitriding. So it's a multifaceted tool rather than just the carburizing furnace, atmosphere carburizing furnace. So those are some of the things that need to be looked at, whether you're going to spend that 150,000 on, a used atmosphere furnace. It's all depending on the work you're bringing through it.
And also depends on also depends on the business case, right?
Sure, and the business case, what customers are you going to attract, and how versatile you want your heat treat to be.
Mm-hmm, mm-hmm. Yep. Also, would you like to add something just to close our 101 session on LPC, and then focus on market trends? So if there's anything else you would like to conclude for LPC and high pressure gas quenching?
I'd just like to say that it needs, with the well, maybe we can talk about that in trends, but with the vacuum carburizing process, it's more along tailoring the case depth and the metallurgy to what you need, and whether it's surface carbon or a precise case depth, or precise metallurgy with retained austenite levels that you need from part to part, or load to load. So it can be changed from load to load and component to component. So that's, I think, the one thing to take away from LPC 101 is that it's quite versatile, and can be material specific or process specific for that case stuff.
Thanks for sharing that great class of LPC 101, Professor Beauchesne. And now let's talk about market trends. So the real question in here is that the process is highly dependent on gears and pinions, which are part of the internal combustion vehicle, right? And everybody's talking right now of how fast is going to be the switch to EVs. And one of the questions that I have is, the market is going to shrink, right? Even more with when electric goes autonomous, right? And what are we supposed to do with that all capacity that is in the industry, right? And the future of heat treat, right? Also, because on conventional, heat treating with atmosphere, there's these big pusher lines, right, that also run gears and pinions, and we have these massive lines also for LPC, you name it, right? Where are we going to locate this industrial capacity? Is it going to be a dying market? What's your opinion on that one? How long it's going to take? Should we continue investing in this stuff or looking at automation? Just want to know your opinion.
Sure. So I can tell you that I've been watching this EV program, the EV programs evolve over the last 20 years. I mean, we've talked about it, I would say more and more in the last 8 or 10 years, but for 20 years for sure. I can tell you that I feel in the last 3 to 4 years, things are moving much faster than we think. I've attended a number of conferences, and I think what we watch is all the companies that are getting up and making presentations about this transmission can do this transmission can do that, this motor can do this motor can do that. And then at the end, we had a consultant get up and say, okay, 40%, only 40% of the people that owned EVs repurchased EVs. So it's all up to the consumer and how fast they're going to switch. But I can tell you that the automotive giants, let's say the OEMs, are switching very quickly. It's moving faster than we think, and that's my opinion, or that's what I see. And you can see just by a lot of the companies saying they're not going to make ICEs anymore, internal combustion engines. That's what I think Volvo said, 2025 or something like that. Don't quote me on that. There's a lot of numbers out there today. And also to address the capacity question. I've heard a lot of people, we're quite active, obviously, in the gear industry. And I've heard a lot of people talk about that, where, hey, there's 13 gears in an automatic transmission today. There's 9 speeds, there's 10 speeds in a gear, in a transmission today. And there's only 4 or 5 in an EV.
That's like that's like the statement. That's like the tweet.
Yep, that's the tweet. But I can tell you, if you've done any production calculations based on the size of the pinions and pinions and internal ring gears and sun gears that are in an ICE transmission, and you've done the calculations for the EV transmissions, from a volume standpoint, and that's what we always talk about, right? How many parts can you get in a standard batch furnace, or how many parts can I get in a load, which is always equates to a cost and a price for a customer. I can tell you that the volume of those parts, the parts are much larger. So when you're talking,
well, are they? Well, why?
Because they're transferring a lot of torque in a few gears.
Okay.
So a lot of the gears are much larger, and some of the volumes for the same number of transmissions take up about the same amount of load size. So that's, I don't want to say that don't worry about it, it's not going to be an issue. I think you're right, there are less gears, so obviously you're processing less material, but there are, from a volume standpoint, an internal furnace size volume, the gears are taking up a lot of space in the furnaces, and from a volume standpoint comparison, similar, or like I say, maybe 80% of the same volumes as what we see today for ICE transmissions. And I may be the only one that believes that or seen that, but that's my personal opinion.
And don't want to put you in spot in here, so don't answer if you have an idea or something. Do you work already with some EV parts on your furnaces?
Yes.
Okay. Are there more? Is the tolerance shorter? Do they take more time to process? Less time to process than regular gears, ICE gears?
I guess I can answer the question. They're similar in time, because they're similar case depths, maybe a little bit deeper.
Time.
Yeah, similar time, maybe a little bit deeper in case depth, but the requirements are much more strict in the way that the tooth formation, the case depth formation is from the root to the flank to the tip. Those requirements are much tighter. Distortion needs to be absolute zero. So if you could find that guy that said he's going to have zero distortion, he's going to sell a lot of furnaces.
Right.
But it's also a factor that they're doing a lot of post heat treatment work to try to get that off. But it also means that the heat treatment must be much more precise, and it must be deeper, longer, or I should say harder at the beginning of the case depth. Whereas that's something that vacuum carburizing can handle in tailoring a recipe. So those are the things that we see in EV. Like I said, the tolerances are much tighter because they're of the NVH, or the noise factor from the transmission. There really shouldn't be any, because you've taken that internal combustion engine out that made all the noise, And now you have some motor noise, of course, but you certainly don't want the transmission to take over the motor noise. So there are a lot of people spending a lot of time doing simulations on distortion, which we've done distortion simulations in our gas quench cells. But it all has to do with how the material is processed as well. So what happens to it before heat treatment? How are they cutting it? All of those factors come into play that where the heat treaters, right, we can point fingers at other people, but in the end, it all comes back to us. So the EV business is looking for carburizing methods that allow for precise control of that gear tooth.
Okay, thanks for sharing that. So let's move on to the next section of the show, which is the one I like the most: heat treat hack or heat treat gadget. Do you have a heat treat hack or a heat treat gadget that you use on a regular basis that you would like to share with the audience?
I would say that the thing we're seeing a lot of, and something that we focus a lot on, myself as well, is small batch processing. Inline processing, just in time kind of processing, which is another, buzzword or buzz phrase that's happened over the years. And that's becoming more and more part of this, also part of the EV, where you have a smaller batch, you can control the quality of the carburizing and the processing, a much better, much tighter tolerances than large batches or large quantity loads. So that's my hack right now.
And just to understand a little better your hack. So you're saying that to process smaller batches in the chamber makes the part better?
Well, sure, because you don't have the risk of non-uniformity across your load,
Okay.
temperature, carbon gradients, and potential changes in your case depth or core hardness from point A or point B in your load.
So you would recommend to people that are struggling with all these things that you just mentioned, if you're having trouble with this, just make the batch smaller, right? Smaller batches, and you'll get some different results. Did I get it correctly?
It has to be the right person to talk to about that. I mean, that's something that
It depends.
I didn't say it twice. No, it has to be the right project, the right person to talk to about. But in fact, it's true. If you have 10 parts versus 2,000 parts, you certainly can control the quality of those parts much better. Also, you have more opportunity to gas quench much heavier parts in that scenario as well. So you get the gas quench qualities as well without the oil. Also, you can get more just in time or plant cadence. And that's what a lot of people are looking for now too, is that to say, I have to get so many parts out in a day. My heat treat, it's not something that I know I can get so many jobs through my machine shop or my CMC, I can get that through there. When it gets to the heat treat, it takes me 5 hours in the furnace. So it's more of a cadence to get through the heat treat, where you need to have a load every 10 minutes or a load every 30 minutes to keep up with the production of the plant. And that's more along the lines of small batch processing. It's not as much, but it is also a benefit to have them smaller, to have the tolerances that you need and require in some of the parts.
Thanks for sharing that with the audience. This is the heat treat hack from the best of the best in LPC, right? And now for the question of the show, Dennis, we have had a great time. It's always great talking to you and talk to experts and people that are actually really passionate about the industry, because this is what we do, right? We were born and raised this way, and there's very little people to share this kind of discussions to, but we had a great time. And now just to finish the show, if I told you what will be a personal experience or advice you will give to the new generation of heat treaters, if you were to travel in time and meet yourself 30 years ago when you were that field engineer, what advice would you give to young Dennis that you learned through your career with experiences, with failures, with wins? What would you tell the kid that it's thinking about taking that job in the heat treat department, that wants to make a name for themselves?
Sure. From the heat treat department and from just in life in general and experience, I think for me, it's never been anything more rewarding than earning the respect of somebody that you respect. So I think that's a very key part of growth and growing in experience, and also surround yourself with smart people, and ask clear and good questions, and have good things to input as well into those discussions, and don't be afraid to have those things. I can tell you in some cases, growing through management, you have some people that are very persistent, and you find out that those are the ones that will be successful because they're persistent and they're asking a lot of questions. They're asking, and eventually they'll ask the right ones to the right people, and they'll go far. So I would say, don't stop asking questions, and earn the respect of the people that you feel are intelligent in the industry. And I really appreciate being on your podcast, and being part of the group of people that you've asked to come on here is flattering, because I respect them all a lot, as well as you. And I think that's really important to bring these people together. And one comment about the topics that we talk about as heat treaters, whether you're a vacuum guy or atmosphere guy or whatever, there's certainly nothing that you can talk about at the kitchen table with your family. And this is a great outlet for that to be a podcast for everybody. So I really appreciate that. And yeah, I don't tell my neighbors anymore what I do. You meet friends at other events, and you don't talk about what you just say. Yeah, we work with in the automotive business,
Right.
or you make parts or something like that. You don't really talk about heat treats. So I appreciate the outlet or the avenue you've given us with this podcast.
No, thank you, Dennis. And the mission here is to have a network and talk about what our passion is. Teach the new generations from the experts, right, to the new generation of people. And I can tell you something. You got my respect. I know I'm not a respected person in the industry yet. Right, on my way, but that's why I like to talk with the best of the best. Thank you very much. Just would like to remind you, we're going to have a weekly podcast. We're on YouTube, LinkedIn, Spotify. We're going to send you this, Dennis, so you can upload it on your LinkedIn and share it so we can go viral. I'm telling you, when I get my YouTube check, I'm gonna share it with everybody, right? And just go like this, Dennis, subscribe. Here's the button below, and just like the video, and we'll see you next week with another episode of the Heat Treat Podcast.
Thank you.